With that, we're now ready to go on and talk about the last thing we have to talk about in statistics, namely selecting the proper statistical test. You may recall that selecting the proper statistical test hinges on remembering what kind of data you have. Nominal data, things in groups, or interval data, things measured along a dimension. The table here gives you your simple key to answering these questions. Table lays out simply what kind of statistical test it is based on the kind of data that you're presented with. Let's walk through this together. If all you have is interval data, all you have is data measured on a dimension, let's say height compared to weight, for example. What statistical test do you do? Correlation. You don't have to know how to do a correlation. All you have to know is if all you have is interval data, the right answer on the exam is Pearson correlation. If all you have is nominal data, looking at how groups of things are related, the right answer is chi-square. Notice you don't have to know what a chi-square is, you just have to know all nominal data goes with chi-square. If you have some combination of nominal and interval data taken together, then the best, most likely answer on the exam is t-test. T-test looks at one interval variable, one nominal variable, and in that nominal variable there can only be two groups. So for example, if I want to compare the heights of men and women, t-test would be a reasonable choice. I want to compare the heights of men and women. Let's take a look at what that might look like. I mean, here's a distribution of the heights of men, and here's a distribution of the heights of women. Comparing men and women. Well, let's see, male and female, that's one nominal variable, and height, that's one interval variable. How many groups? 1, 2, that looks an awful lot like a t-test. That's easy. Please note one key limiting factor for a t-test. A t-test can take 1, 2 groups only. T-test, only 2 groups. 2 groups, t-test. T-test, 2 groups. T-test, 2 groups, 2 groups, t-test. T, 2, T, 2, T for 2, and 2 for T. La da 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 da. T-test, 2 groups only. If you have more than 2 groups, not a t-test. Ladies and gentlemen, let me try to motivate you to learn this content. If I find out that any of you mark a t-test for more than 2 groups, I will find you and I will sing to you again. T-test, 2 groups only. So suppose I want to compare the heights of men and women, and I know you've been busy studying, you probably don't realize it, but we discovered life on Mars. I want to compare the heights of men, women, and Martians. Can I do a t-test? No. Why? It's got 1, 2, 3, more than 2 groups, so I can't do a t-test. Instead, I'm going to do an analysis of variance. Why do I do an analysis of variance? Because I have 1, 2, 3 groups. I'm now out of t-test territory. I'm into analysis of variance. If you get confused about what we've been talking about, let me go back and emphasize your key default choices. These are your rules of thumb choices. These are the ones that are most likely to be the correct answers. If you have all interval data, it's a correlation. If you have all nominal data, it's chi-squared. If you have interval and nominal data combined, your best choice is a t-test. T-test for 2 groups only. Now, to conclude, I want to spend a minute going through just some more details for what you need to know about each one of these different kinds of statistical tests. The basics are given here in this simple presentation, but you may be asked for a little bit more detail. So let me go through and just deal with that. First, I want to make sure you understand what meta-analysis is. Meta-analysis, ladies and gentlemen, is something we haven't talked about before because it's different than other statistical techniques. Meta-analysis is not how you analyze your data. Meta-analysis is how you combine the results of different studies done by different people, different times, different locations, and get a single p-value that summarizes all the studies. It is basically a mathematical mechanism for conducting a literature review. See, prior to meta-analysis, you were trying to decide what's the best treatment for prostate cancer. So you read the literature and you saw treatment A and treatment B and treatment C, but by your impression, the weight of the literature said treatment A was best. Meanwhile, you were reading the same literature, and your subjective sense of the literature was that treatment B was best. You see the problem? You both read the same literature. You both come to different conclusions. Once again, we need a referee, and the referee is called meta-analysis. I'm going to combine all those research studies you read mathematically and come up with a single p-value to give me a conclusion as to which treatment is better in a way we can all agree with. Once again, how you do that is not tested. Just when you do that is the test issue. Let's go on and talk about a correlation coefficient. Correlation coefficient, remember, is something used for all interval data. Height versus weight, for example, or length of time studying versus test score, all interval data. Here are the key things that you should know about a correlation coefficient. Correlation coefficient, written as letters small r, range from a possible -1 through 0 to a possible +1. It's impossible to have a correlation outside that range. How strong the correlation is depends on simply how far it is from 0 in either the positive or the negative direction. It's distance from 0 in the absolute value sense that determines the strength of the correlation, not the positive or negative sign. Make sure you're with me here. Which one of these is the strongest correlation? -0.65 or +0.56. The strongest correlation is? Right, -0.65. Cover up the sign, read the number. Larger number is stronger correlation. What the sign tells us is not the strength of the correlation. The sign tells us the direction of the relationship. A positive correlation means the best line that describes the data has a positive slope. A negative correlation means the best line that describes the data has a negative slope. How strong the correlation is simply is a matter of how tight the points are around the line. If they prescribe a clear, clean line, that's a strong positive correlation with this kind of a slope. If they in fact form more of a cloud, where you can see that it's a positive slope, but in fact the points are more of a cloud, well, that's a somewhat weaker positive correlation. If you can't see any slope at all, let's make sure you can see a slope there. If you can't see any slope at all, then we would call that a zero correlation. This would be a scatter plot for a zero correlation without any slope discernible in one direction or the other. What would be the correlation coefficient that best describes this scatter plot of data? The correlation coefficient would be probably 0. Now why? Well, because a correlation doesn't look for any possible relationship. A correlation only looks for a linear relationship. A zero correlation doesn't mean there's no relationship. A zero correlation means there's no linear relationship. So this, even though it has a clear curvilinear relationship, computes as a correlation equal to 0. And one final point. Correlation does not by itself mean causation. A whole lot of things in the world have very strong positive correlations or even negative correlations, but there's absolutely no causal connection whatsoever. Look up here a second. Look at my hands going up and down. Up and down in perfect synchrony, right? My right hand, my left hand, it's a perfect +1 correlation. Now you tell me, is my right hand causing my left hand to move, or is my left hand causing my right hand to move? Neither. I am making them both move. The fact they're going up and down together doesn't mean one makes the other happen. There are a number of things empirically that have strong positive correlations with no causal connection whatsoever. For example, there's a strong positive correlation between the number of people that drown in a given community and the amount of ice cream consumed in that community in a given year. A lot of drownings, a lot of ice cream consumption. What's going on there? People eating ice cream and going swimming like your mother told you not to? No. It's all about heat. When it's hot, people eat ice cream. When it's hot, people also swim. One doesn't make the other happen. They just both occur in situations where it's hot. Consider this a landmine waiting to trip you up on the exam question. They're going to give you the results of a study, and they're going to say, based on this study, the researcher would conclude, if they show you a strong negative correlation between exercise and blood pressure, if you take that strong negative correlation and you pick the choice that says exercising more will reduce your blood pressure, you're wrong. Even if you think that's true in reality, you can't infer that from a mere negative correlation. Do we understand each other? It's a trap waiting to happen. Correlation by itself doesn't mean causation. Let's go on and talk about interval and nominal data combined. Combining interval and nominal data together, our first choice, of course, is always a t-test. A t-test compares the means of two groups. It's t for 2. Now there's some variations here I want you to be familiar with. Consider the following. Suppose I give you a test today, and then I give you a test a month from now. And I'm going to compare the results of you today versus a month from now. Well, let's see, before and after, that's a nominal variable, and test score, t-test, because you today are linked in some very clear way to you a month from now, right? And so the answer to that is not a mere t-test, it's a matched pairs t-test. Why? Because the people are linked together in a one-to-one relationship. Anytime you're doing a comparison between husbands and wives, brothers and sisters, or people selected to be companion pairs in different legs of a study, you're talking about a matched pairs t-test. If you can't use a t-test, instead, analysis of variance. A one-way analysis of variance is simply an analysis of variance where you have 1, 2, 3, 4, more than 2 groups. It's going to be a one-way analysis of variance. And a two-way analysis of variance, something I believe right now you're unlikely to see on the exam. A two-way analysis of variance simply compares two nominal variables with one interval variable. A simple example of that might be as follows. I'm interested in examining the blood pressure of men and women who are from the U.S. and Mexico. Blood pressures of men and women from the U.S. and Mexico. Male and female, that's one nominal variable. U.S. and Mexico, that's two nominal variables. Blood pressure, that's my interval variable. Two nominal, one interval, that's going to be a two-way analysis of variance. Again, I don't expect you to need that for the exam. And finally, chi-square, your last default choice. All you need to know about chi-square simply, it's for nominal data only. All we're talking about is looking at groups of things, comparing one set of groups to another set of groups. Consider the following simple question. Are men more likely than women to sit at the front versus the back of the room? Are men more likely than women to sit at the front versus the back of the room? Well, let's see. We have male versus female, and then we have front versus back. How much data do we have? Two variables, one interval, gender, and seating position, a second one. Everything in there is nominal data, therefore chi-square is your answer. Now we call this particular example a 2x2 design. But a chi-square can be used on any number of cells. I can use a chi-square if I have a 2x3 design. I use a chi-square if I have a 3x3 design, etc. There's no limit to the number of cells. The limitation is it's all nominal data. Folks, once again, all I'm trying to get you to do here is not understand how to run these statistical tests, not understand how they're computed. All the test asks you to do is understand when they're used. Once again, remember your simple default choices. If it's all interval data, it's correlation. If it's all nominal data, it's chi-squared. If it's nominal and interval data taken together, the answer is t-test for two groups only. We've just finished statistics. Congratulations. Let's take a break.